Welcome to 5G Hub. In this video, we will talk about key 5G differences and challenges. While the 5G network provides lots of features from the previous generations of mobile networks, there are fundamental differences that need to be considered during 5G network design and deployment. First, higher frequency operation. Second, ultra lean design. Third, self-contained structure and duplex scheme, and low latency support. Higher frequency operation and spectrum flexibility. The range of available spectrum for 5G has expanded in comparison to previous generations, unlike LTE, for example, which supports licensed spectrum up to 3.5 GHz and unlicensed spectrum up to 5 GHz. 5G supports licensed spectrum from below 1 GHz up to 52.6 GHz. 3GPP release 15 divides into two different frequency range 1 and frequency range 2. The frequency range 1 is below 1 GHz and frequency range 2 is above 20 GHz, as you see in this image. So operation, for example, at mmWave or high band, as you see on the second part of the image, offers the possibility for large amounts of spectrum and very wide transmission bandwidth. This will enable support of high data rates for end users compared to the latest LTE networks, LTE Advanced, for example. However, it should be noted, frequency range 2 or mmWave bands are prone to higher bus loss and a much smaller cell coverage. These issues need to be addressed by utilizing advanced techniques like massive MIMO antenna and beamforming, for example, and also dual connectivity for user equipment to utilize the both frequency range 1 and frequency range 2 simultaneously. Second, ultra lean design. One issue with existing radio access network is the high overhead due to control channel signaling. Such overhead traffic, sometimes referred to as always-on signals, are independent of actual user traffic and enable functionalities such as identifying the right base station and transmitting system information to user equipment. Although in current LTE deployments, the amount of actual signaling traffic is acceptable, the ultra-dense deployment of future 5G network are not scalable with the present approach. 5G ultra-lean design principle aims to minimize the always-in, as you see in the above control signal, to minimize this ratio, and also reducing the overall network energy consumption and system interference. Third, self-contained structure is a frame structure which provides downlink and uplink resources efficiently for minimizing latency. It contains downlink control, uplink control, and data either in downlink or uplink direction, all in a single subframe or slot. Thus, the name self-contained. With this frame structure, latency can be reduced to enable real-time and mission-critical application for 5G. Number 4, duplex scheme. This is mainly determined by spectrum allocation and operational bands. For lower frequency bands, allocations are often paired, implying frequency division duplex utilization. But at higher frequency bands, unpaired spectrum allocations are common and require time division duplex utilization or TDD. 5G can operate in both paired and unpaired or FDD and DDD using a common frame structure. Basic 5G frame structure is designed with both half and full duplex operations in mind. In half duplex mode, the device can't transmit and receive at the same time. This includes TDD and half duplex FDD operations. In full duplex operations, simultaneously transmission and reception is possible with FDD as typical example. Finally, low latency support. One of the major characteristics of 5G from the beginning was the possibility to support a very low latency access for different services. The big step toward achieving this goal was implementation of something is called front-loaded reference and control signal in 5G. By locating the reference signals and the downlink control signaling carrying scheduling information at the beginning of transmission and not using time domain interleaving across of the M symbols, a device can start processing the received data immediately without prior buffering, therefore minimizing decoding latency. The possibility for transmission over fraction of slot or mini slot transmission is another feature in 5G to reduce latency up to 1 millisecond or less. Thank you for watching and see you in next video.